Good afternoon, friends. We have to study the wireless access protocol, access logic control into the last lecture. Into this lecture, we also consider the access for control logic. Once again, what is the priority behind this? Myself, Sachin Tate, I am working as an assistant professor into the S&D group of institution and research center, EULA. So once again, we can study that how this access control logic is there. What is priority of that logic? Use the three values of IFS: SIFS, PIFS, and DIFS. What is SIFS? Is short form of IFS, is shortest IFS for all immediate response in the action. See later. The PIFS, point coordination functions, is the measure length of IFS used by the central control in the PCF scheme within the ports. DIFS is the distributive coordinated function of IFS, is the longest IFS use minimum delay for the asynchronous frame containing for the access. SIFS use acknowledgement station within the SIFS to determine transmission opportunity has highest priority in preference to the station waiting. PIFS is the point coordination function of IFS. Acknowledgement station response within the acknowledgement after waiting SIFS gap. No collision detection, so likelihood of collision greater than the CSMA and collision division. MAC clear acknowledgement given efficient collision recovery. SIFS provide the efficient delivery to the multiple frame LLC PDU station within the multi-frame LLC PDU to transmit send to the MAC frame one at a time. Each frame acknowledged after the SIFS by receive. When source receive the acknowledgement immediately after the SIFS send next to the frames in the sequence. Once station has contended for the channel, it maintain control of all the fragments sent. SIFS use CTS clear to send. Station can ensure data frame will be get through by issuing RTS. The destination station should be immediately response within the CTS if ready to receive. All the other stations here RTS and differ. Full responses C point coordination function. Now, what is PIFS and DIFS? PIFS use centrally controlled by issuing pole take precedence over the normal contention traffic. Frame using the SIFS has precedence over the PCF pole. Now, DIFS is used all the ordinary asynchronous traffic. Basic access method. Now, this is diagram showing all this content of the access method. Immediate access when the medium to be free longer than the DIFS, it is BG. Then DIFS, PIFS, and SIFS is there. Will be see the deferred access. Now, backup window is there. It should be give the slot time. The next frame versus the time. This diagram should be self-explanatory, showing what is DIFS, what is PIFS, what is SIFS. That should be explained here. Point coordination function. Alternative access method implemented on the top of TSA. Polling by centralized polling master point coordinator uses the PIFS when issuing the poll. PIFS smaller than DIFS can size medium and block all the asynchronous traffic when it issue the polls and receive the response. Wireless network configures so number of stations within the time sensitive traffic is controlled by the point coordinator. Remaining traffic contended for the access using the CSM. Point coordinator polls in the round Robin station, configure for polling. When poll is issued, poll station may be responsive using the SIFS. If the point coordinator receives response, it issue another poll using the PIFS. If no response during the X1 turnaround time, the coordinator issue the polls. Then super frame. Point coordinator would be lock out asynchronous traffic by using poll. Super frame interval defined using the first part. Super frame interval point coordinator polls round robin to all the stations configured for the polling point coordinator, then ideal for the remainder of superframe, allowing the contention period for the asynchronous access at the beginning of superframe. Point coordinator may be size control and issue poll for the given time. The time varies because of the variable frame size issued by the responding station. The rest of the superframe available for the contention-based access at the end superframe interval. Point coordinator content to the access using the PIFS. If ideal, point coordinator gain immediate access full superframe period of long time. If BG, point coordinator must be wait for the ideal and gain access. Result of for for shorten superframe period for the next cycle. So MAC timing PCF superframe construction should be self-explanatory in this diagram. That superframe is the fixed nodular content, then PCF variable length per superframe, then DCF if it's BG medium, then PCF is deferred, PCF optional, then if superframe is fixed nominal size, then foreshortens actual superframe period. That should be self-explanatory in this diagram. Now IEEE 802.11 MAC frame format. It should be FC DI address 1, address 2, then SC address frame body and CRC. MAC frame feed. Frame control is the type of frame control management of data provided the control information included when the frames is to or from DS fragmentation information and privacy information. Duration and connection ID. If used the duration field indicate time in microsecond, channel will be allocated for the successful transmission of MAC frame. In some control frame contains associations of connections ID, address, number of meaning of address field depend on the context. Types included the source, destination, transmission, and stations and receiving stations. MAC frame field sequence control at 4-bit fragment number subfield, 12-bit sequence number frame between the transmission and receiver. Frame body, it should be the MSDU or fragment of LLC, PDU or the MAC control information. When frame check sequence is the 32-bit cyclic redundancy is changed. This is all about this lecture. We can study the next part in the next lecture.